Welcome to Render's first user conference. Now, Render started 8 years ago, and this is our first user conference. And so naturally the question is, well, why didn't we do it before? So we only started building out a marketing team just about a year ago. And when I thought about trying to get 100 engineers to organize a user conference, that was not a risk I was willing to take. So again, this is our first user conference. I want to thank you all for being here. I think this is going to be great. And I was only half joking with the engineering thing because building for our customers has always been our top priority over things like sales and marketing. And that is core to Render's DNA. I was the fifth engineer at Stripe, and that's a photo from 2011. And when people hear that, they often ask me, well, why aren't you on a beach somewhere? Why are you trying to build Render an application platform? The reality is that I started Render because I wanted to solve a large and ambitious problem and play my part in the evolution of technology. I saw infrastructure as the common thread that was slowing down so many builders, so many application developers, and I wanted to give them superpowers. Just think about everything it took to put your application, a complex application, in production in 2018. You provisioned VMs and kept them patched. You set up load balancers and then SSL certificates and made sure to keep them updated and renewed. You wired up a CI pipeline and made sure all your tests passed and you could launch safely. You provisioned a database and then replicas and failover mechanisms and then made sure that you could actually fail over at 2 a.m. You created a cache. You set up a queue. You set up workers to drain them. And if you knew how to do it, you maybe set up a private network to connect all of your applications together. And then you bolted on logging, metrics, and alerting, just so you could know what the hell was going on in your system. And this was all before you started dealing with the complexity of Kubernetes. But none of that was your actual product. It was the cost of building your product. You had to architect everything to be reliable, secure, and scalable. And then you had to pay that cost, that work, forever. You had to manage it forever. I believed then, as I believe now, that application developers should not have to think about any of this. I believed that if we can design a cloud that made infrastructure just work, without forcing you into a specific framework or a specific architecture, then adoption would follow naturally. And that turned out to be true. Today, hundreds of thousands of companies are building on Render. And many of you are sitting in this room here today. All of these builders share one common belief with us, that the cloud does not have to be hard. It can be as easy as pushing your code, or these days, asking your agent to push the code it wrote. It makes me so proud to see how far we've come and just how many developers are now shipping faster with Render. Over 400,000 developers join Render every month. Nearly 10 million services are currently running live on Render. Collectively, these services handle over 200 billion web requests every month, and all of these numbers are growing very rapidly. But behind these numbers, we're also seeing a big change in how applications are evolving to use infrastructure. Until just a couple of years ago, infrastructure was relatively static. For a given deployment of your application, the shape of your infrastructure stayed pretty much the same. You wrote your application to enable your users to do a deterministic set of things. Create something, send a message, buy something. And then you deployed it with exactly the infrastructure that it needed. Web services, APIs, databases, caches, workers, and so on. So you knew what your application needed in production. You configured it statically, and then maybe you scaled it with fairly simple primitives. But AI apps are fundamentally different. They are dynamic applications that go beyond existing infrastructure patterns. Now, in addition to you defining your application statically, the applications themselves are provisioning their own infrastructure resources. This is typically done to execute user-generated code or to run really dynamic workflows as part of a user request. So there is now an exponentially growing set of scenarios in which the static relationship between code and infrastructure is dissolving rapidly. Let's take a research agent as an example. A user asks a question. To answer it, the agent decides it needs to analyze maybe 40 records. For the next question, it needs 450 or 100, and the number could really change depending on the question asked. And the quantity, that change in quantity is actually the easy part. One of the questions might require lightweight web scraping, or web search, or a headless browser, or perhaps 128 gigs of RAM to crunch a really massive data set. And task durations differ as well. One of the tasks might finish in milliseconds, and the next one might take hours, sometimes maybe even days. So what we're learning is that any request can trigger hundreds or thousands of different tasks in ways that your code can never really know in advance. When you try to build this with serverless providers, and your agents quickly run into the limits imposed by the platform. Execution is capped at a few minutes, memory at most a few gigabytes, the application size maybe at a few hundred megabytes, and the underlying runtime remains incredibly inflexible. The tasks that your agents can do on these front-end only systems remain very constrained. What you need is the flexibility and the scalability of real servers backed by your own runtime dependencies. But building AI workflows using a server-like system is an incredibly complex operational challenge. You need to provision multiple worker pools to handle all the different tasks that an agent can run. You need queues, caches, and storage to orchestrate those tasks and manage state for very long-running processes. And you need to set up observability so when something breaks, you know exactly when, where, or how, and then if needed, you can retry things. The more powerful you want to make your agent, the more complex it becomes to build the system and maintain it and grow it. So when I look at this, I see the same thing that I saw in 2018. A new class of infrastructure toil that is slowing application developers down. So we naturally asked ourselves, what if all of this just worked? What if, instead of building and orchestrating complex distributed systems, you could define in code any task that your application might need to execute, and you did not have to think about the infrastructure behind it? Now, 3 things need to be true for that. Number 1, you need instant execution. Your application cannot wait after it triggers a task for 45 seconds for the task to start executing. It needs to feel serverless and instant, and it needs to be built accordingly. Number 2, you need a flexible runtime. No 30-minute timeouts, no one-size-fits-all specs. You need all the flexibility of long-running environments with a full array of compute sizes, ultimately any kind of app bundle size, and maximum concurrency. And finally, you need managed stateful orchestration. Your application needs to run chains of tasks that persist for hours, days, or even months. And the state inherent in these tasks must be maintained at all times. This is what we've been building. A compute model that allows your application to spin up any workload it needs at runtime without any pre-provisioning. We call this application-defined compute. It's a model that allows you to develop more intelligent and more dynamic applications safely. Instead of predefining the infrastructure for your application, you allow the application to define what it needs at runtime with the right guardrails. With application-defined compute, we're building an entirely new set of primitives that allow AI applications to run on render as easily as web apps. All you need to do is push your code. And of course, this works seamlessly with the rest of our stack. Builds, deploys, logging, observability, all of it just works. Render workflows is the first primitive that is part of our application-defined application-defined compute stack. And to tell you more about it, here's Slav Borets.
Hey folks, so application-defined compute, it's a very powerful primitive. Today I actually wanted to get on stage and answer the question, what does application-defined compute looks like in practice? So instead of another diagram, I actually wanted to show the product in the context of a real agent that we built internally. So over the past couple of months, obviously, as many other teams, we've been building internal agents. One of these examples is our own data science analytics agent. We built it to help internal teams, business teams to answer basic data science questions. But at the same time, we realized this agent can be pushed significantly further beyond just the basic data analysis. So we turned this agent into a full-on data science machine. It can analyze data, it can generate reports, it can run on schedule, and it can do a lot of data crunching on it. As part of this work, some of the tasks take seconds, some take minutes, some potentially can take hours. Additionally, depending on the user query, the analytics agent can request a lot of compute or a little compute. And that unpredictability really made it difficult for us to really properly architect the system at scale. So before workflows, this is the stack we were considering. One, just typical web service, and then create a background worker to offload all the complicated compute. And in order to make sure the background workers work as reliably as we need to, we would need a queue and a bunch of auto-scaling logic and pair that with a lot of retry logic. At the end of the day, a lot of complexity, and given those agents are managed by internal teams, nobody wanted to undertake this complexity on their own. Instead, we decided to replace the stack with workflows. So as you can see, we replaced the entire background stack with simple workflow service. In order to enable workflows, all we had to do was to add a simple decorator around the core agent loop and deploy it to render. Now, every time the agent loop is called, all we need to, the render provisions the infra stack, offers full observability, and gives the application what it needs on the fly. And given our agent is file system first, each individual tasks that are being provisioned are today they get independent containers, and agent can do its work without running over each other. Let me actually show you a real demo of how this works live. So here's the agent, and let's start with a simple data query about our own signups in the month of May. So while the agent is thinking, you can actually quickly see that we immediately provisioned the compute within less than a second, and all the tasks that the agent is crunching through are actually fully displayed on our dashboard. For each individual agent run, you can see all the work that the agent is doing, and all these tasks are actually retriable. If something fails, you get complete visibility into inputs and outputs for each task, and you can actually see all the other logs as well. So when the agent is being run, you can actually quickly debug the issue live, or if something goes wrong, you can actually debug it in the past as well. And then given the query that was asked, it turns out in this case, agent needs to both look through our own file system, pull up the right skills, download the right metadata, and then start going through SQL and running SQL queries one after the other. So once the work is complete, you can actually see we got the full graph, really in-depth analysis, and now we can actually start following up, asking follow-up questions. So it turns out in this case, in the month of May, something happened. There was a period on May 20th when there was a giant spike in our sign-up rates. Obviously, this data is a bit abstracted away, but it's still fairly accurate. Now, given we're using workflows, we can actually ask follow-up questions. Workflows themselves maintain state, and you can actually just resume the conversation and ask follow-up questions without the need to pull in state again from a separate provider. So in this case, let's ask what happened in the month of May. Again, given this is an agent, it knows the context of the question, it knows where the data come from, and shortly, it will give me a depth analysis as to what actually changed in the period versus the other period versus past month. And I hope we'll get a concrete answer. Wow. In this case, it actually asks a few follow-up questions. So let's send clarification. And again, each individual turn has dedicated compute given to it, and all the metadata and all the retry logic is applied to each individual step of that agent work. So in case something fails, the steps will be automatically retried. And then also for auditing purposes, you can quickly go back and analyze the work of the agent using our dashboard. So while the agent is running, we can actually see the results in a second. I've rerun this before. There you go. So when we asked this question in the past, the answers we got actually pointed to the fact that on May 20th, there was a direct spike in our organic search and indirect traffic, indicating that it was actually an external event that caused a giant influx to our service. And when we look at the metadata, we actually, it turns out one of our competitors had a bit of an issue, and a lot of customers decided to consider render in exchange of this provider that they were using in the past. Now, obviously, data science is looks simple on the surface, but the real power is making this agent scale. Scaling these agents is actually where the complexity lies. Today, as a company, we really want to remove the need from developers to think about infrastructure at all. Independently, whether you're building data science agent, really complicated coding agent, or trying to take on the world with a net new agent harness, our goal is to handle the infra for you. All you need to do is to define the application code. We will build a stack that will serve you and your customers well. Obviously, as Anurag mentioned, application-defined compute is a big umbrella term. Today, we're launching Render Workflows, the first product in this category, and then shortly after, we will launch sandboxes. We believe workflows and sandboxes combined will give you and your customers all the compute you need to build effective, long-running, and stateful agents. With that, I really want to hand over the conversation, the stage to Taj, where he'll talk about what it takes to build, debug, and scale applications on Render using AI tools. Thanks.
Literally on the walk over here, I think I saw half of you with like Claude Code open on your laptop. Yeah, agents are how we all build today. We just saw a lot of pretty cool demo about how you can build agents on Render, but to build those agents, we are all using coding agents as well. And today, agents write a lot of our code. We have the ability now to go from prompt to a working full stack app in minutes, working on your machine, localhost. And that's all great, but it takes a lot to get from that locally working code to a running application that you can distribute to your users and build your business. It requires CI/CD, infrastructure, observability, stuff that your agent doesn't necessarily have context about, and you become the bottleneck again. That's where Render comes in. With our CLI or MCP, whichever one you prefer, your agents now have all the necessary context it needs to operate autonomously. Instead of you having to go bounce back and forth between dashboards across multiple providers, With just a render CLI and MCP, your agent can get access to CI/CD information, observability, and debug any issue and continue to iterate for you on your behalf. Let's see what this kind of looks like in practice today. Let's take a pretty basic application, something that requires a web service for your full stack web app, Postgres for your production database, and a bunch of workers for billing jobs, emails, syncs, whatever it is. And let's say you get a user report, a bug report that they can't upgrade their billing plan, and you want your agent to investigate and fix it. So you log in to your customer support portal on Intercom or Salesforce, I guess, and you see that this user couldn't upgrade. You go and test it in your own application. Sure enough, you get the same issue. All you do is take a screenshot of that and dump it into your coding agent of choice, Cursor, whatever it is, and ask it to go fix it and make no mistakes. You see it loads the render debug skill, and in this case, it's using our MCP. I personally prefer our CLI, but in this case, using our MCP, and it's listing all the logs, getting metrics, getting the current state of what production looks like today. Gathering all this context that otherwise you would have to go back and forth and copy and paste. Now it comes up with an investigation, a hypothesis. Let's use shared storage between the worker and the API service. And it wants to use render key value to solve that. And you say, go ahead. The agent starts churning through it, editing code, pulls up even more skills like our render key value skill. If only the tokens were that quickly in real life. And yeah, it's editing all the code. And you can see it's editing our render.yaml file. And here you see that after it wrote all the code for the shared cache layer between your web service and your workers, it's also editing the envars across them and calling out that it needs a key value. And then it's pushing to GitHub. Render then automatically created a full stack preview environment, so you and your agent can actually test these changes in an isolated environment. And now it works. So there was a lot there. Just to break it down, what you got here was first context through the render CLI and MCP. So your agent understands exactly what's going on in production and can really hypothesize a working solution. It gave you control. Of course, using our CLI and MCP, your agent can one-off create that key value. It can one-off edit the envars for your web service. But for those who aren't full of the YOLO life mode, they want control. And that's why we offer blueprints, where your agent specifies exactly what infrastructure it wants to change, and it goes through your code review process. So your team can make sure that the infrastructure changes proposed are safe and exactly what you want. And we also give you confidence. Not only do you get a preview of that front-end experience, but you get a full stack preview. You got a preview of your Postgres. You got a preview of this key value instance. And you got a preview of your workers, all in one isolated environment for you to test exactly what the change looks like in production across all your different infrastructure parts. And yeah, that was a fun demo. But this is really how teams are shipping today on render. Hundreds of thousands of teams. You'll hear from Every pretty soon about how they've pretty much automated their application development using agents and the render CLI without any dashboard intervention or manual intervention. Customers like Ferndesk migrated within hours their entire production stack, something that would take days or weeks before, just using the render MCP. And that's just where we're getting started now. We have quite an exciting roadmap ahead, things that I'd love to talk to you all about during happy hour if any of this excites you. Stuff like granular permission controls for exactly what your agent can do or can't do. Audit logs, agent identities, so you can federate the same level of access to all your team's agents. Things like infrastructure time travel, so you can go back in 3 days and 30 seconds to exactly the config change that you want to go and revert. Or things like cost controls. Or also remote dev environments. Your agents can work in the cloud in a production-like setting without you having to keep your laptop cracked half open at the gym. These are all things that we're doing so that your agents can do more of the work. So teams can keep all the control and your app can get better every day. The safe and intelligent cloud. Thanks. Now I'll hand it back to Anurag to close us out.
Thank you, Tej, and thank you, Slav. I'm really excited for you to see what we've been building with application-defined compute and with workflows, and how your agents can now ship faster with render CLI and MCP. Our next two speakers are perhaps two of the most prolific and effective AI builders in the industry. First, Ben Broca, solo founder of Polsia. Now, how many of you have seen Polsia ads in SF? Yeah, all right, well, there you go. Now, Polsia scaled to more than 10 million in ARR with just a single employee who's also the founder, and you're going to hear from him shortly. And then you'll hear from Kieran Klassen, who created compound engineering. And if you've been on Twitter, you probably know what compound engineering is. And he uses it to build Cora, which is Every's email assistant. And he does this without writing a single line of code. Now, I'm really excited to hear from Ben, Kieran, and the rest of our speakers today. But I also feel really honored that all of you made the time to join us here. So I really want to thank all of you again for coming.